Well, good day, everybody. My name is Hilde Stenuit, and as Anita kindly introduced, I am with Space Application Services, so coming from a very different direction than Sheila, who just talked, so that's interesting. So Space Application Services is a company with space engineering and space research expertise. The company has a headquarters in Belgium and offices in the Netherlands, where I am based and enjoying the nice weather. And we have offices also in Germany and a subsidiary in Houston. And I saw that my colleague Virgil Romero from Houston is also among the participants. So thanks, Virgil. So I very much appreciate the possibility to talk here on the CMS Astro today. And I want to thank the organizers, as I think this is a truly exciting topic. And I also want to thank Ahmed Khan, who I also saw in the participants, for putting us in touch. So what I would like to talk to you about is explain a bit what it is that we do. You see ice cubes on the screen, so I want to explain to you what ice cubes is. It's a service, and I'll say a bit more on the service type and what it is that we do and the capabilities. And of course, specifically on our thoughts on the relevance of cellular agriculture, cellular AgBio, and space, and how this is linked to us and what we do. So my background is actually, well, in my former lifetime, a plasma-astrophysicist, and then I started working with space application services, first on spacecraft and space station operations, and then in a mission of in a function of mission scientist for the International Space Station, supporting the European Space Agency, so coordinating with the other agencies on research complements. And then now I support this IceCube service. So let me talk a bit about that and say a couple of words on who we are and what we do. So as I think you probably all know, space and the International Space Station give access to a very unique environment with assets that cannot be reproduced here on Earth. And so with the service that we set up, we provide fast and direct access to any organization to this unique environment of microgravity and radiation. Because we think that the more organizations and the more people that have access to space and microgravity and radiation, the more benefits it will accrue to all of us. And so this service, so the acronym stands for International Commercial Experiment Service, CUBE service. And we own this facility, of which you see an image inside the International Space Station. And it can accommodate a wide range of research and technologies. And we typically carry them on board on the International Space Station in this type of units or cubes that are customizable. And so you see some of them here in blue and some here on a picture that was taken on the space station. And as you see, they don't even need to be cubes. In fact, this one in front is a plant growth cylinder, let's say. And so with what we basically take care of is the space-specific aspects of the processes of doing research in space. So the company Space Application Services is a company with a wide heritage in engineering for space. And we do what we like to call spatialization. So that means that we translate what researchers do on Earth into a space environment. And so we also give access to organizations that have never done anything in space. So we try to make this access as direct or as simple as possible, in the sense that they don't need to bother about learning about space processes and safety and all of that, but that the people we work with can concentrate on their research activities. We set up this service globally. So we started it in Europe through a public-private partnership with the European Space Agency. And then in the US with my colleague Virgil in Houston, we work as implementation partner to the, I'm sorry, my phone is ringing. We work as implementation partner to the ISS National Lab. And I saw that our colleagues from TechShot will also be presenting, so I'm sure Jean will also mention more about implementation partners. And so for the other continents, we work through either direct user relationships or as well as through partnerships. And so why do we do this? So our scope is to allow for anyone to make use of this unique lab and testbed in view of space and space exploration. So for research and technologies that are relevant for space, for Moon, for Mars, beyond. But also surely to make space part of everyday's value chains or everyday research here on Earth, and to use these unique assets of this space environment for the benefit of us Earthlings and our research and development activities. So to put space at work, let's say, for us Earthlings. And so exactly that dual scope is what I want to address specifically here in the Cultured Meat Symposium, Astro, here today. So specifically thinking about life sciences R&D. So what can we find in this space environment, in this unique lab, which cannot be found on Earth? And I think maybe many or some of you are very aware. So what we see in general is an increased cell growth, replication, and virulence. We also see a kind of enhanced stemness of stem cells. Cells also form more easily complex three-dimensional structures without the need for scaffolds, allowing to create more representative tissues, for example, than in the human body, and allowing for better models for studying cell behavior. But also microgravity induces gene expression changes in all living things, basically. Another aspect is that crystallization of proteins or molecules in general is also interesting in microgravity. So some molecules form larger and more well-organized structures or crystals in microgravity, and so lead to better structural measurements. And so all of these aspects actually bring forward very interesting benefits. So in the past, actually, these effects have been scientifically observed and studied, but we are now at a point that these scientific observations, let's say, can be proactively utilized for application area. And so I think for people coming from area of cultured meat, I'm sure that some of these effects that I try to put in short bullets, that they talk to you in an interesting way of that's an effect that can serve our goal related to cultured meat R&D activities or research activities. And so I want to show you how we typically work through our IceCube service and what capabilities are in a number of specific areas. For example, everything that relates to 3D cell culturing, tumor, organoid, spheroid growth under microgravity. So the way we approach this is that we build samples. So you put your samples together with the nutrients that they need, with the fixative that you want at the end of your protocol under certain temperature conditioning, maybe with the right analysis tools, a microscope, and all of that can be integrated together in this type of cube, or that can be this size or bigger. We have some cubes developed that are based on well plates. We have some cubes developed that are based on tubes, for example, for seeds or for algae or others. And so each of these can come with their own in situ analysis or with a camera, and that can be adapted or customized according to the specific aspects that we are interested in investigating. And so it can be at the level of one cube, or we're also building a number of platforms that can address, for example, 3D tumor, organoid, and spheroids. A second, and so we bring them on board. We launch them on one of the vehicles that go to the International Space Station. They're installed in our facility. They get power and data, and then the researchers can run their protocols either in an automated way or through commanding and getting real-time data back to and from Earth. So that's one example of how we can work topics related to 3D cell culturing. A second is this crystallization that I mentioned, and that can be proteins, large molecules that can be related to drug development. So there again, these samples of proteins, they can be put in these gel tubes at the right temperature and be brought in this incubator that is developed by a Japanese partner of ours called JAMS. And so we have done a couple of those missions very successfully so far. And so again, this incubator is launched to the space station, is installed in the facility, gets its power and data, and so it can run the research protocol. So these are two examples of this type of cubes or platforms or units, as you want to call it, how we can address certain aspects or certain sectors of research and benefit of these effects, these unique effects of this microgravity and radiation environment. So coming to the scope of why we are here, so cellular meat or cellular food in space. So my point here is that I think cellular agriculture or cell cultured meat and space is actually a very relevant marriage. So first of all, for the more obvious reason that our dear astronauts on long-term space missions, they will need to eat. And so cellular or non-animal based food will be very crucial, if not even mandatory. And we heard also about the Deep Space Food Challenge in that context from Dane. So for sure, there is interest from NASA, but also from other space agencies to think how cellular agriculture can be integrated in their research roadmaps. But I also think that marrying cell cultured meat with space is also interesting from a narrative standpoint, in the sense that food production anywhere is highly relevant. Also, when you think of space missions, but also a previous speaker mentioned these remote areas where you can do in situ food production. So I think also in that sense, it's an interesting marriage between cell cultured food and space. But then there is this second angle. So this is basically space for space, you could say, and we can touch on topics like, okay, cellular agriculture or meat or food for long missions, but also topics related to biomanufacturing, in situ biomanufacturing. But then there is also this second angle that I mentioned before, which is how can we make space work for Earth? And so how can we proactively utilize these effects of microgravity that acts on anything biological? How can we utilize these effects in our advantage for research, for R&D, for us here on Earth? And in that context, I think it is interesting to ask if in the R&D that is being done in the context of cell cultured meat or food, how we can make these assets of, in particular, I'm thinking of microgravity, can make them serve positively. So for example, can we use this environment of space and microgravity to create cell factories? Can we use space in general to set up more resilient, more automated, more optimized food systems? Maybe it's a bit further, but also the topic of plant stem cells. So how can we benefit from this microgravity environment to help these research, this R&D here also relevant for us Earthlings? And so we are working on a couple of projects that are related to those topics, and we're definitely interested in linking up with many of you around these topics, around these research topics under those two angles, so space for space, but also space for Earth, and to serve, let's say, that marriage that I think is very interesting between cellular agriculture and space. In fact, over the last 2 years, we have been doing a study co-financed by the European Space Agency, where we looked like what are those areas that can make the best use, that have the most potential to put space to work. So to make use of space assets, to make use of microgravity for Earth purposes, what are traditional, what are new markets, applications, and what are technologies and analysis tools of relevance. And out of that study, we arrived to a concept of a modular platform with state-of-the-art diagnostics and an associated business model, partnership model. And so we have completed that study. In fact, you see some of the main application areas that came out of the study where we think the highest potential is. So, and cellular agriculture is definitely one of them. And the type of modules that would be part of this platform that we would like to create. And so we're definitely looking for materialize this modular platform so that it can also serve again, make use of this environment on these different application areas, making use of these different adaptable modules that can be customized to serve either cellular agriculture or to serve more biotech related topics or more biomanufacturing, for example. And to look for these applications and with the associated in situ diagnostics that can be built in this platform. So again, this is work that is in progress. But if any of you say, okay, that's interested, we touch on similar applications, similar modules, or we have capabilities that we think could be nice to throw in the mix or of this nice marriage, then I would be definitely happy to link with you and to see how we can collaborate on it. So basically to conclude, so what I wanted to address is that I think the CMS Astro organizers are hitting a very interesting point, because I do think that it's a very relevant and interesting marriage to put cellular agriculture and space together for the reasons that I mentioned, both for the angle of space exploration, so astronauts' food, sustainable in situ food production, but also for the Earth applications, for R&D related to food, also related to food production or biomanufacturing. And so from our side, we are involved in projects that relate to cell culturing, genetics, biomining, biomanufacturing. So, I mean, the topics that you've seen, but for sure, we're happy to collaborate and in research projects around and to identify innovative solutions in those area with people that come from exactly the other side of the marriage, let's say. And so that's what I wanted to emphasize here. And that's what I wanted to mention, and let's see for questions.
Thank you so much, Hilde. I think, you know, especially that last slide, it really kind of gave me that moment that we are covering such a very specific topic that is really exciting, that we are actually here talking about this. And, you know, going back to it, when our team first started organizing the first CMS, which had nothing to do with space, that was when Paul Shapiro's book was not even released yet. That was when Blue Nalu and Lou Cooperhouse was giving a talk in Hawaii before one of his co-founders came up to him and said, let's turn this into a company. Before YC had a request for startups, which now is supporting so many startups in the space. So now being able to talk about bioreactors, incubators in space is so exciting. So thank you. Thank you for that. We're going to go into questions. We see there's a question here. Hilde, are you talking to Axiom Space to put this on their commercial space station? I'm not sure if you're familiar with that. Any comments or thoughts on that?
Yeah, we're definitely we know the friends from Axiom Space. So I think we're at a very interesting point in general in what is called commercial access to low Earth orbit, and the research that can be done and the applications that can come out of this access to space. And I think services like ours or like TechShot or others, I mean. I think they're making a nice bridge right now to allow for anybody to have that access. And I think also it's still a nice size of a world in the sense that we do know most of each other. So yeah, we know Axiom, we work with them, we know the friends from TechShot, we know, even though we're on the other side of the ocean, definitely, and we're talking to each other. And rather than seeing each other at this moment as competitors, I think it's rather how can we build, how can we collaborate and really make the most out of this access to space that is really relatively new, that it's possible for anybody other than through the agencies, which are there for very good reasons. But it does take a while, again, for good reasons mostly. But I think it's very exciting that there is now the possibility for direct access, that there is the possibility that there will be a commercial space station or more than one, like Axiom is eagerly working on. So for sure, we collaborate with all of those friends around the world.
Great. And I alluded to this earlier when we were having the panel, but and your team has been working on space applications for some time. But what advice do you have for those that want to start a space project but haven't either made the connections or haven't done anything actually in space? Any advice on that starting point?
So yeah, you mentioned that our company, Space Application Services, actually exists quite a while, so we can rely on quite some heritage. But I think we're also eager to say that we do have some characteristics also from what is called new space. So in terms of the agile approach, the fast approach, streamlined processes, and so on. And that's, I think, what I would mention as advice to new people that want to come and do startup activities, or make sure that you're agile, make sure that you set your vision of where you want to go, where you want to say no to. And that's something that Andre will love, my colleague, because that's also something, a discussion we regularly have. But then also make sure to network, and to build those bridges. And that's what we see that allows us to build on some of these topics, even topics that we don't necessarily have a strong background in, which because they're not space, but we just go out and network and talk to people and put it all in the mixer and see what innovative solutions can come out. And so I think that on the one hand, the agile and the strategic direction, but at the other hand, throwing new things in the mix and checking them against your direction. I think that would be probably my advice. And talk to us to give you access to space.